Right, so we're going to work with Matlab a little bit. If you open the Matlab software, somewhere you should have the so-called command window with the command prompt. Usually there are other windows also. For example, there is the workspace window where you see the variables and stuff like that. I don't have the default settings for the Matlab because I don't care usually with the other windows. But let's concentrate on the command window right now. So if you want to define a vector, you can use lowercase notation. For example, a equals, and then you have to use the bracket, the square bracket. And to separate the entries, you can use space, but you can also use comma and space, or just comma. It doesn't matter. And then you close it and the vector with the bracket. Then with enter, it shows you the result. Also in the workspace, it tells you that you have a new variable, and it shows the values, at least some of the values. Nice thing about Matlab that if you want to go back and add some, you forget something, you don't have to write down the whole thing. You can use the up arrow to make modifications to the previously entered command. If you don't want to see what you entered again repeatedly, then you can use the semicolon and it doesn't show what you are entering. Again, you can use the back arrow, the up arrow, to go back to the previous commands. Also later, if you want to use A, or you want to check the values of A, you can just enter A and then the enter. If you want to enter a matrix, first of all note that Matlab is case sensitive, so if you enter capital A, it says that A is undefined, but it's smart enough to guess that maybe you meant lowercase a, which is already a vector. But no, that's not what I mean. I want now to specify a matrix, which is 1, 2, 3. Let's say that it has 2 rows. The next row must be started with the semicolon, or actually that shows the end of the previous row. And if the first row has 3 entries, that means there will be 3 columns. That means the second row also has to have 3 entries. Actually, let me write then a bigger matrix. So this is 3 rows. Let's say we have a 4th row. And then we finish the matrix also with a close bracket. So we have a 4 by 3 matrix now. For example, this matrix can be multiplied from the right with something that has 3 rows, and it doesn't matter how many columns. So this is 2, 4, 6 entries in the first row. Six in the second row, and then we need one more row. 0, 0, 0, 2, minus 3, minus 4, minus 5, or minus 6. Okay, so this is a 3 by 6. So 4 by 3 A matrix and 3 by 6 B matrix should be possible to multiply them together. We get 8 times B. And here's the answer for 8 times B. You could also denote it with the C matrix if you want to use it later, for example. And note that B times A is undefined because the dimensions don't match. And it even tells you this error, that incorrect dimensions are used. Some other things, the transpose. So we have this A matrix, which is a 4 by 3. The transpose is denoted with prime notation. So it's not the T that we used. That's mostly because we don't have a superscript notation here and that we could use for the transpose. So we have the prime notation for the transpose. And you can check that A prime, which is the transpose of the transpose, is the same as the A matrix. Another way to check this, if you subtract it from the A matrix, you get the zero matrix. Let's see what else to do with this. Well, let's look at some web work problems. So the idea is that if you have huge matrices, you cannot do this really by hand. It will take forever if you want to do some arithmetic. So you want to do it with a computer. Note that copy pasting doesn't really work most of the time. If you try to copy it, you get some garbage. For example, the numbers are not separated neither with space nor with comma, so just a big huge number. So instead of that, what you can see in WebWork for this problem is that you can download these matrices A, B, C, or whatever matrices are given, as a CSV file, which means a comma separated values file. Excel can read it, so depending on what kind of browser you use, either when you click on this, it downloads it. For example, Google Chrome would download it, and then you can open it with Excel, Microsoft Excel, and then copy and paste the matrix. Or in my case, Safari decided to open it itself, this matrix, and from there I can copy and paste it. So this was the A matrix. The way I can copy and paste it, then I say that this will be the A matrix. Actually, here you can also see that the rows don't have to be separated with semicolon. You can also just separate it with the enter sign. And you can also see that the previous A matrix is now overwritten with the new A matrix. Then we also create the B matrix with copy paste. Again, you might have to use the Excel, Microsoft Excel, for pasting it from it. So this is the B matrix and the C matrix. Don't forget to open and close the matrices with bracket. Not parentheses, not braces, but brackets. Please look up the difference between brackets, braces, and parentheses. It becomes very important when you use software. So we have the three matrices, A, B, C. You can also see actually here on the workspace. And since these are bigger matrices, to list all the entries, it just says the sizes, that A is a 5 by 8, B is a 6 by 8, and C is a 5 by 6. By the way, it also tells you that Matlab uses by default double precision, which is quite good for computations, even when the matrices are integers. So we have to calculate A times B transpose plus the scalar 3 times C. The way you enter this in Matlab, A times B transposes with prime, and then plus 3 times the C matrix. And that's it. If everything you did correctly, then the result should be correct. Unfortunately, there is no way to copy and paste this whole matrix back into WebWork. So what you have to do is enter it one by one. So 96 minus 79, then 77. What you can do is, maybe one possible way to speed this up is if you use the tab to go between entries. So minus 36, and then tab takes me to the next one, next in the row, minus 49, 115, tab, 77, 66, 37, and so on, let me not do the whole thing. And then, well, it says it is not correct. Clearly because I didn't submit all of them. So you have to submit all of them. And you cannot see it, only I can see the correct answer. So you see that whatever I submitted was correct. You don't get partial credit for this. The whole thing has to be correct. Next problem. To solve the matrix vector equation AX equals B, where A is a given matrix and B is a given vector. So again, this is too big to do it by hand. Actually, we haven't talked about how to solve a matrix vector equation. All I said that if you have the inverse, you could do it, but we don't want to use the inverse. Usually we don't want to use the inverse. So let me mention how to solve this. First of all, let's create the A and B matrices that are given in the problem. So A equals the A matrix and then the B vector, column vector. Doesn't matter whether you use lowercase or uppercase, but the notation usually is that B lowercase letter denotes vector. So the idea is that if A was a scalar, if everything was scalar, the way you would solve this is you would divide through with A. A is multiplying X from the left, so theoretically, if there was such thing, we would divide from the left. Remember that the multiplication is now not commutative, so multiplication from the left or from the right is different. So imagine that this was scalar, but also it's not commutative. So if you divide through by A, you have to divide from the left. Then that means that X, how do you divide B from the left? Well, there is the backslash, which then seems to suggest that you are dividing B by A from the left. It turns out that this is exactly how Matlab works. This is not the inverse that you get. What you get is a sophisticated method that it's even better than the Gauss-Jordan elimination to solve the linear system. And you get the X matrix by A backslash B, which tries to tell you that you kind of divide B from the left with the matrix A. And this is not the same as multiplying with the inverse of A. Actually, it's much better. So the answer is 5 minus 4, 1, 9. Don't worry about the zeros there. Even if it's not 0, the answer is supposed to be integer. So there might be some rounding error, unfortunately, because we are doing so much calculation in this process. But in this case, the answer is supposed to be integer. What happened? I think I made a mistake somewhere. 5 minus 4, 1, 9, 7, 6, minus 7, minus 6. I got lost here. Minus 1 and 4. And this is not correct. The next one, for whatever reason, although I told you not to use the inverse in usual calculations, but in some cases we might need the inverse of the matrix. So the comment to calculate the inverse, first of all, let's create this new matrix A. And then to calculate the inverse, this is just the function inv. So inv parentheses, that will give you the inverse of the matrix. Now, if A is integer, the inverse will almost never be integer. This will be some long decimal number, typically infinitely many decimal digits. So I didn't want you to enter this whole big matrix entry by entry. I only ask for one column, in this case the third column of the matrix. And what you can do is copy and paste one by one the entries. So although Matlab uses double precision, you don't see that many decimal digits here. You only see how many? 4 decimal digits. But double precision is more than 4. That's something like, what, 16? I forget how many. But double precision would be 6. So there might be some rounding error. Let's hope that there are no rounding errors. Yes, there are rounding errors. So if you copy and paste it in and it doesn't seem to be correct answer, then first of all check that you entered everything correctly. Sometimes it's easy to leave out some minus signs, but I didn't do that. So if the problem is not incorrect copy and paste, then it's the problem with the rounding errors. So you want to see more decimal digits and you want to use more in the web work. You want to enter more decimal digits. For that you want to use long format of numbers. So format long will give you more decimal digits. And then we have to go back and with the up arrow and calculate the inverse of A again. And now you see that there are much more decimal digits than before. So let's copy now these, the third column of this. Most of the computations can be solved in Matlab in this course. There will be some theoretical questions, but most computations can be solved. Of course, you will have to show the work. So this is not correct because I used more decimal digits. If that's not very convenient many times to see so many decimal digits. So if you want to get rid of it, you have to change back to format short. Format and short. If you want to see how the command works, you can enter inv, help command, and that will tell you what it does for calculating the inverse. If you don't know the exact command, then instead of help, you can use look for command. For example, you can say that look for transpose if you forget how to do the transpose notation. And here is one of them we already found. So then it looks not just the exact command transpose, but all related commands. And here is transpose. It actually tells you that if you use the dot, that will be the conjugate transpose. No, I'm sorry, this is the non-conjugate transpose. The prime notation is the conjugate transpose, but since I used only real valued matrix, then this is the same as the regular transpose. So if I have A here, A prime is the transpose, and A dot prime is also the transpose. But for complex matrices, it would be different. So there will be some additional calculations that you're supposed to do by hand. Please try to do them by hand and maybe check your answer with MATLAB.